Hey guys at home, a couple of things today. First of all, we had some issues yesterday with that Quest in that our school firewall is blocking the AP classroom for some reason, and they're working on it. So those of you at home were all able to access it except one, but the kids in class could not, and so they didn't really have a very fair shot because they had less time, and then they also kind of had to move through it all at the same pace, so people felt rushed, and so it wasn't really fair between the two groups to count it as test points. So I'm just going to put it in the homework point category, just as a 20, not a 20, a 16-point homework assignment. However, on Friday, if you, because there were 21 of them, but when it goes AP, 70% or better for BC is considered a 5. So what I would suggest though is that on Friday there's a Google Meet where I'm going to go over those. And I think even if you're below 16 or, even a lot of you had if you had 20 out of 21, but maybe you really want to know the one you got wrong, you can still show up as well. There were, I'd say about half who had a really solid 19 or 20 out of 21, but then there was a good chunk who were in like the 12, 13 area, and then one or two really low. And you guys, I would highly suggest you show up on Friday for the Google Meet. I'm not going to require it because it's test prep. You're going to be testing on Monday or Tuesday depending on A, B, or DL. But when we go through these from that AP classroom, I'll have a hard copy and I'll be writing on it, so I won't be in AP classroom. And we'll just go through them one by one, and I think that'll clear up a lot for this chapter. Again, not required. I'm not going to force you to review for the test, but a really good idea, I think. We seem to be sitting at about 3/4 of you really get this chapter, and a fourth of you really still have some issues to clear up by Monday or Tuesday. So I think that Friday will really help, as will our review packet that will start tomorrow. So a couple things about worksheet 10 here. The B kids will finish it in class, but I'm going to be pointing out a few things for them. When it says, what can we say? I'll do this 2A with you. So when we say that the definite integral from, or improper definite integral from a to infinity of f of x equals k, what that means is it converges. So f of x converges to some constant k, all right? And this says g of x is under f of x. So we've got a convergent function and we have g writing under it. So when it says, what can we say about the definite improper integral of g of x, we can say that g of x must also converge because it's under a convergence. So for example, if this guy converges to, let's say, 2, right, then anything under it is going to have a finite amount of signed area as well. So therefore, g of x must also converge. You could even be a little more specific to a number less than k. But that's what these are asking you for. So a couple of these will be inconclusive, like you won't know. For example, if you're above a convergent, you may or may not converge. So just keep that in mind. We crossed off number 3. I'm also going to cross off number 4 because this is leading you towards working with series, and we aren't going to work with those till second semester, so there's really no point for that one. Number 5 is good. It's great. Very typical AP. Love number 6. Remember that the definite integral from 1 to infinity of 1 over x to the p dx is always equal to 1 over p minus 1. That's worth memorizing. So ones like this, when they're multiple choice, you can do a shorter way. On the key though with number 7, I made it too fast. And I said, oh, this is 1 over x to the p with p less than 1. And when we're less than or equal to 1, it diverges. But I neglected the limits, and actually this one does converge. So be careful on the key. I put diverges. This does converge to one of these numbers. That was just me going too fast, and so I'd beware of you doing that too. We can only use that 1 over p minus 1 when p is greater than 1 if we're going from 1 to infinity of 1 over x to the p, not from 1 to 2 or 0 to 1 or any other. All right. So, what else did I have to say about this one? That one's good too. Remember your integration techniques when you're integrating these. Okay, so I'm just going to say, when a minute I look at that, my brain goes arctan. All right. Next up, we're good with that one. Good with that one. I did post the key. There's something else. Oh, this guy right here is just a beast. On the key, I did it with shells. But you guys don't really seem to like shells this year. So remember, if you're going to revolve around the y-axis, and you'll be doing the area under here, which appears to be infinite, but it's not, and you're going to be revolving it this way. We draw our representative You can do it with shells, and I think it's a little easier, and that's what's on my key. But for those of you who are anti-shell people, when you draw your, trying to get it to go blue here, sorry. It's being finicky. Maybe my black one will. My black one's not even writing. Oh. Oh, I know why. Oh, there we go. What is going on? All right, we're going to try it. Oh, I did it with my fingertip. Not the pen. All right, now I'm good. All right, so I'm going to draw my representative rectangle, which makes this a dy problem. And if you're going to do that, then when you have the point x, f of x, we're not going to be using, right, that we need to know the x value when we do our big R. So we have to be really careful here because we need to have the x as a function of y. So you should write y equals e to the negative x squared. You'll have to solve it for x and then go through the process. And what's going to happen is you're going to end up blah, blah, blah. I still want you to have to do some of the work. You're going to be integrating negative the natural log of y. And you can pull the negative out front. And you might say, how can you have a negative natural log? You can. It's not the natural log of negative y. That you can't do. But the natural log of y you can negate. So this has to be done by parts or be memorized if you're going to do it with the dy. So just know that. You'll get the same answer, but on my key, I did it with shells. This is a really hard question, by the way, so you should be looking at the key, but I want you to stay away from it as much as you can. Friday's task is going to be doing some more FRQ like problems that have this topic in it. But this is back to Calc AB about maximums. Remember, those occur at critical values, so we'll have to find the derivative of the area function, which means you're going to have to write a function for the area first, okay? And you're going to have to take its derivative. So you might just want to call it a of x, and then find a prime of x, and we'll be looking for where it's 0, and then you have to prove that that's the same as the x coordinate of the point of inflection. So you'll need a double prime. And you'll have to find where that also equals 0. And it should be at the same number. And lastly, on this page, again, this is an AB, but you guys have to know all your AB. The only thing is, don't forget maximums and minimums, again, occur at critical values. And this guy is going to go to an improper integral, and I want you to use the limit process. So make sure you show all your limits. And you should finish in the amount of class time that there is. I do think you'll need to look at the key a little bit for these two FRQs, but I'm hoping after Friday, after we practice, we can stay a little bit farther away from it. All right, have a good one, you guys. 10 is due today. Those in class are going to be picking up the chapter review for that we're going to work on tomorrow and Thursday. I'll try to post it for you guys at home too, in case you have more time today than you have at home tomorrow, or than you want to spend on this at home today. All right, there we go. Deactivate my pen.